What if your reality isn't as solid as it seems? What if the world you perceive as fixed and unwavering is, in fact, something far more fluid and mysterious? For centuries, we've built our understanding of existence on the idea that things are either here or there, on or off, alive or dead. But what if that fundamental binary is an illusion? This isn't just a philosophical ponderance, it's a question that emerges from the very heart of quantum mechanics, the rules that govern the universe at its smallest scales. And to understand it, we need to start with a rather peculiar cat. Picture a sealed box. Inside is a cat, a vial of poison, a radioactive atom, and a Geiger counter set to trigger a hammer if the atom decays. According to the rules of quantum physics, that single atom exists in a state called superposition. It is both decayed and not decayed at the same time until someone looks at it. Therefore, the cat inside the box is astonishingly both alive and dead simultaneously. This is the famous and famously mind-bending thought experiment devised by physicist Schrödinger. It was meant to highlight the sheer absurdity of applying quantum rules to the everyday world. But what if the absurdity is the point? What if superposition isn't just a quirk of tiny particles but a fundamental property of everything, including you and me? This idea pushes us into truly uncharted territory. We're about to explore a possibility that stretches the fabric of reality itself. What if our entire universe and every single one of us within it exists in a state of quantum superposition? What if every choice you've ever made, every path you've taken, and every path you didn't are all equally real, playing out in a vast, branching tapestry of existence? This journey will take us from the perplexing behavior of electrons to the grandest scales of cosmic structure, challenging everything we think we know about time, identity, and the nature of being. We're not just observing a scientific curiosity, we are investigating the profound possibility that we are all living, breathing participants in the universe's greatest mystery. So let's open that box and see what's inside. To grasp this staggering idea, we first need to anchor ourselves in the quantum rules that make it possible. At the subatomic level, the universe operates with a completely different set of instructions than the world we see and touch. The most fundamental of these is the principle of superposition. Think of it not as a particle being in one place, but as a cloud of possibility. An electron isn't just here or there, it exists as a wave of probabilities spread out across all the locations it could possibly be. It is, in a very real sense, in all those places at once. A simple way to visualize this is with a coin. Imagine you spin a coin on a table. While it's a blur of motion, it isn't definitively heads or tails. It's in a state that combines both outcomes. The moment you slam your hand down to stop it, the spinning state vanishes and the coin settles into a single, definite reality, heads. In the quantum world, that spinning state is superposition. The coin is both heads and tails until the act of measurement forces it to choose. This is the essence of the famous wave function collapse. The wave function is just a mathematical description of all those probabilities, and the instant it is observed or measured, it collapses from a haze of maybes into a single, concrete is. This leads us directly to the observer effect, one of the most debated and misunderstood concepts in physics. It's not necessarily that a conscious mind is required to look at the particle. The observation is any interaction that forces the quantum system to declare its state. It could be a photon of light hitting an electron, or a Geiger counter registering a decay. The very act of trying to measure something disturbs its delicate state of superposition, forcing it to snap into a single, classical reality. This is the bizarre disconnect physicists have wrestled with for over a century. Why does the quantum world, with all its fuzzy probabilities, give way to the sharp, definite world of our everyday experience? Our classical reality seems so solid, so real, but it's built upon a foundation that is fundamentally uncertain and fluid. The chair you're sitting on feels utterly stable, yet it's composed of atoms whose electrons are buzzing around in a probabilistic cloud, never truly in one fixed location until some interaction pins them down. This paradox, this chasm between the tiny quantum building blocks and the large-scale world we inhabit, is the central mystery that opens the door to our incredible premise. For decades, the leading explanation for this quantum weirdness has been the Copenhagen interpretation. This view, championed by figures like Niels Bohr, tells a rather dramatic story. It says that the wave function, that description of all possibilities, exists only as a potentiality. It's not real in a tangible sense until the moment of measurement. At that precise instant, the wave function collapses and a single reality is chosen from the infinite menu of options. In this framework, our spinning coin is truly in a state of flux, and our act of looking is what forces it to become heads or tails. The cat is in a ghostly state of both life and death, and it is the very act of opening the box that brutally forces the universe to decide its fate. This idea places a strange emphasis on observation, and for many it feels unsatisfying, almost as if reality is waiting for a conscious being to give it permission to exist. But what if there's another way? What if the wave function never collapses at all? This is the radical and elegant proposition put forward by a young physicist named Hugh Everett in the 1950s. His many worlds interpretation offers a breathtakingly different answer. Everett proposed a simple yet monumental shift in perspective. The wave function is real and it never collapses. Instead, every single possible outcome of a quantum event actually happens. When that radioactive atom in Schrödinger's box has a 50-50 chance of decaying, it doesn't choose. Both outcomes become real. The universe itself splits or branches into two separate, equally real timelines. In one branch, the atom decayed, the poison was released, and the cat died. In the other branch, the atom did not decay, and the cat lives on. There is no superposition of a half-dead cat. There are two cats, each in its own complete and independent universe. This isn't just about cats in boxes, of course. This branching happens constantly at every conceivable quantum junction. Every time an electron has a choice of paths, every time a photon could be reflected or absorbed, the universe fractures. Each of these tiny splits creates new, parallel worlds diverging from our own. The result is a mind-bogglingly vast multiverse, a cosmic tree with an infinite number of branches, each representing a different way reality could have unfolded. In this view, you are not a single individual on a single path. You are a multitude. For every decision you've ever agonized over, a career move, a conversation, a turn left instead of right, there is a version of you in another world who made the other choice. Every possibility that quantum mechanics allows is realized somewhere in this grand, sprawling tapestry of existence. The beauty of the many worlds interpretation is its sheer simplicity. It removes the mysterious, almost magical collapse of the wave function. There's no special trigger for observation. Reality just keeps evolving, branching endlessly. It treats the entire universe with one set of rules, the quantum rules, from the smallest particle to the largest galaxy. This idea transforms our thought experiment from a paradox into a description of reality. We are not just observing the box from the outside. We, the observers, are part of the quantum system. When we open the box, our own state becomes entangled with the cat's. We don't cause a collapse. We simply branch into the version of ourselves who sees a live cat and the version who sees a dead one. Both versions are equally real, both equally convinced that their outcome was the only one that could have happened. This perspective doesn't just solve a physics problem. It fundamentally reshapes our understanding of our own place in the cosmos, suggesting that our lives are but one thread in an unimaginably rich and complex fabric of realities. This breathtaking vision of a branching multiverse is a powerful idea, but it forces us to confront a critical and deeply puzzling question. If superposition is a fundamental property of nature, why don't we ever see it in our daily lives? You never walk into your kitchen to find a coffee mug in a superposition, both on the counter and on the floor at the same time. The world we experience is stubbornly definite. The key to resolving this paradox lies in a process known as quantum decoherence, and understanding it is the crucial step that allows us to scale these quantum rules up to the size of the entire universe. Imagine a single, isolated electron. It can happily maintain its superposition, its wave-like existence spread across space because it's not being constantly jostled and bumped. Now picture that same electron as part of a much larger object, like a dust mote floating in a sunbeam. That dust mote is made of trillions upon trillions of atoms, each with their own electrons, all interacting with each other and with the countless photons of light hitting them from the air and the sun. This is the essence of decoherence. It's the process by which a quantum system loses its delicate superposition state because it unavoidably interacts with its surrounding environment. Each tiny interaction, a collision with an air molecule, a stray photon, acts like a mini observation, constantly measuring the system. These interactions effectively leak information about the system's state into the environment. The coherence, the special quantum relationship between the different possibilities, is destroyed by this constant bombardment. The system is forced to behave classically, appearing to pick a single, definite state. The superposition isn't gone. Its effects are just smeared out and become undetectable because they are entangled with the vast, chaotic environment. This is why large objects appear stable. They are experiencing decoherence on an unimaginably fast timescale. Now, let's take this logic to its ultimate conclusion. If quantum mechanics is truly universal, if it is the fundamental theory describing all of nature, then there is no reason it should only apply to tiny particles. The same mathematical rules that govern an electron must, in principle, apply to planets, stars, and even the cosmos as a whole. This leads physicists to the concept of a universal wave function. This would be a single, monumental mathematical equation that describes the quantum state of the entire universe at once. It would encapsulate every particle, every field, every force, and all their possible configurations. In this framework, the universe itself is the ultimate quantum system. Before any hypothetical measurement, what would this universal wave function describe? If the universe is an isolated quantum system with nothing outside of it to cause decoherence, then it could, in theory, exist in a state of superposition. It would contain a blend of every possible history and every possible future, all coexisting simultaneously. The universe wouldn't have a single, fixed past leading to a single, determined future. Instead, it would embody a vast landscape of possibilities. There would be a version of cosmic history where a particular galaxy cluster formed slightly differently, where Earth never developed life, and where you were never born. All these potentialities would be real components of the universal wave function. The cosmos would be in a state of pure potential, a quantum tapestry woven from every story that could ever be told. The profound implication here is that the definite history we learn about in school, the Big Bang, the formation of galaxies, the rise of life on Earth, might not be the only history. It is simply the one we have decoded into. Our local environment, our planet, our instruments, and even our own memories have all become entangled with a specific branch of this universal wave function. We don't experience the superposition of the cosmos for the same reason we don't see a superposition coffee mug. Our act of observing the universe from within it causes a process of cosmic-scale decoherence, locking us into a single, consistent timeline. We are like characters inside a book, only able to read the single narrative thread of the page we are on, completely unaware of the infinite other stories contained within the library of the universal wave function. This perspective suggests that the solid, classical universe we perceive is not the foundational reality. but rather an emergent property that arises from the deeper, more fluid quantum whole. This brings us to one of the most intimate and unsettling questions raised by quantum physics. What is the role of your own mind in all of this? If the universe exists as a haze of probabilities, what is the special ingredient that turns that haze into the solid, consistent world you wake up to every morning? The act of observation seems to be the trigger, but what exactly qualifies as an observer? Is it a machine, a cat, or does it require something more? A conscious awareness. This line of thinking leads to a hypothesis that is as profound as it is controversial. The idea that your consciousness itself is the fundamental force that collapses the wave function, that your perception is what crystallizes reality. This perspective is most famously associated with the von Neumann-Wigner interpretation. The brilliant mathematician John von Neumann, followed by the Nobel Prize-winning physicist Eugene Wigner, argued that if you trace the chain of observation back to its source, you inevitably arrive at consciousness. Think about it. A Geiger counter can detect a radioactive decay, but does it truly observe in a way that creates a definite reality? The counter itself is just a collection of atoms which should also be governed by quantum rules. It could enter a superposition of having clicked and not having clicked. The information from the counter then travels to a computer screen, which also exists in a quantum state. The light from the screen enters your eye, striking photoreceptor cells again, just complex molecules. The signal travels along neurons, which are physical systems. At what point does the maybe become a yes? Von Neumann and Wigner proposed that the final link in this chain is the one thing that seems to stand outside the purely physical description, your conscious experience. It is the act of you becoming aware of the result that finally forces the entire chain to snap into a single, classical reality. The implication of this is staggering. It suggests that you are not a passive inhabitant of a predetermined universe. Instead, you are an active participant in its creation. Every time you look at something, you are performing a kind of magic, winnowing down infinite possibilities into one tangible truth. The moon is not there when you are not looking at it. It exists in a suspended state of potential locations until your gaze forces it to be exactly where you see it. This view elevates consciousness from a mere byproduct of brain activity to a fundamental component of physical reality. It's a return to an almost idealist philosophy where mind precedes matter. Yet, for all its intrigue, this idea makes many physicists deeply uncomfortable. The primary objection is that it seems to insert a mysterious, non-physical element into the clean, mathematical framework of quantum mechanics. It creates what's known as the problem of tails. If consciousness causes the collapse, what about the parts of the wave function that are not observed? Do they simply vanish? And where do we draw the line for consciousness? Does a cat have enough consciousness to collapse a wave function? What about a worm or a bacterium? The interpretation risks creating an arbitrary dividing line in nature. Furthermore, it seems to fly in the face of the principle of locality, suggesting that a thought in your brain can instantaneously affect the state of a particle on the other side of the galaxy, a notion that clashes with Einstein's theory of relativity. This is why the many worlds interpretation offers such a compelling alternative. It sidesteps the entire controversy by removing the collapse altogether. In that view, your consciousness doesn't cause anything to collapse. It simply splits and travels along different branches. There is no special moment where you force reality to choose. Instead, there is a version of you who saw the live cat and a version of you who saw the dead cat, and both are equally real. Your sense of being a single, continuous self is an illusion. You are a multitude experiencing every possible outcome across the multiverse. This eliminates the need for consciousness to have a magical collapsing power, but it replaces that mystery with the equally profound mystery of an infinite number of parallel selves. So, where does this leave you, the observer? It presents two fundamentally different ways of understanding your place in the cosmos. In one, you are a powerful focal point, a sculptor of reality whose every glance shapes the universe. In the other, you are a boundless entity, living out every possible version of your life across a vast multiverse. Both ideas challenge our deepest intuitions about identity and existence. They force us to reconsider the very nature of what it means to be a self, living in a world that is far stranger and more wonderful than it appears. The alarm clock rings, and in an instant the blur begins. You don't simply wake up, you awaken to a chorus of potentialities. One version of your hand slams the snooze button with a groan, burrowing back into the warmth of the blankets. Simultaneously, another version of that same hand swings out, full of purpose, and silences the alarm for good, pushing back the covers to start the day. This isn't a moment of indecision, it's a moment of quantum divergence. As you shuffle toward the bathroom, your path isn't a single line. You see faint, ghostly afterimages, translucent versions of yourself splitting off at every micro-choice. One ghost version turns left to check their phone on the nightstand, and while the solid-seeming you turns right toward the door. Both actions are happening, both are equally real in their own branching streams of reality. This quantum haze permeates the most mundane routines. Standing before the open refrigerator, you are in a superposition of breakfast choices. A shimmering outline of your arm reaches for the eggs, while the arm you feel as solid grasps the box of cereal. You pour milk into a bowl that is both full of crunchy oats and in another layer of existence, sizzling in a pan next to scrambled eggs. The morning news on the television reports a single, definite story, but the radio in the background crackles with the faint whispers of alternative headlines from adjacent timelines, a major scientific breakthrough in one frequency, a minor political scandal in another. Your morning commute becomes a symphony of possibilities. You are both stuck in traffic, tapping your fingers impatiently on the steering wheel, and cruising smoothly down an open lane, listening to your favorite song. At every intersection, the universe fractures again. You take the usual route to work, while a quantum double makes a spontaneous turn down a side street, discovering a charming new coffee shop that, in your primary timeline, remains forever unknown. This constant branching extends to your social interactions in ways that are both subtle and profound. As you walk into your workplace, you greet your colleague. The you that exists in this moment is the one who offered a cheerful good morning. But there is another you, just as real, who was momentarily distracted by a text message and offered only a silent nod. That version of your colleague now carries a slightly different impression of you into their day. In a meeting, when you present an idea, the reaction is not a single outcome. Your proposal is simultaneously met with enthusiastic approval from your boss and with skeptical questions from a rival. Both outcomes spawn entirely different trajectories for the project and for your career. Every word you speak, every gesture you make, exists as a spectrum of probabilities, each one cementing a different relationship dynamic and a different future. The true psychological weight of this existence would be felt in the quiet moments. Looking in a mirror, your reflection might hold a faint, unsettling depth. For a split second, you might catch a glimpse of a face that is slightly more tired, or one that looks more refreshed. The you from a branch where you went to bed earlier, or the you who stayed up late to finish a passion project. Your memories would feel less like a fixed record and more like a contested landscape. You'd have a strong recollection of a childhood birthday party at the park, but also a nagging, ghost-like memory of it being rained out and moved indoors. Both would feel true because on the quantum level, both are true. Your sense of self would become fluid. You wouldn't be a single, continuous personality, but a central theme around which countless variations endlessly play out. The ambition that drives you in this branch might be tempered by contentment in another. The fear that holds you back here might be overcome by courage in a parallel world. Your entire identity would be a superposition of all the people you could possibly be. Now, let's take this concept to its logical and truly dizzying conclusion. If the universe is constantly branching at every quantum possibility, then every single choice you make, no matter how trivial, becomes a cosmic event. This is the butterfly effect on a scale that is almost impossible to comprehend. The classic butterfly effect suggests that a small change, like a butterfly flapping its wings, can set in motion a chain of events that leads to a hurricane on the other side of the world. But in a quantum multiverse, the butterfly doesn't just influence the weather in one timeline. Its single flap literally creates an entirely new universe where the consequences of that flap unfold. The same applies to you. Your decision to hit the snooze button one more time doesn't just make you late for work. It initiates the birth of a completely separate reality where a slightly more tired version of you navigates a day with a domino effect of subtle differences. The version of you who got up immediately enters a world with a different morning rhythm, perhaps catching an earlier train, having a different conversation, and setting their life on a trajectory that diverges more and more dramatically from the snoozing version with each passing moment. Consider the simplicity of choosing a beverage. In this reality, you might pour yourself a cup of coffee, the caffeine sharpening your focus for a morning meeting. But in the universe branching off from that precise instant, the you who opted for tea is experiencing a completely different biochemical reality. The lower caffeine intake leads to a more relaxed contemplative state, which changes the tone of your contributions in that meeting. Perhaps the coffee you argues a point more aggressively, securing a new project, while the tea you listens more carefully, picking up on a crucial detail that coffee you missed. That single, seemingly insignificant choice at the breakfast table doesn't just alter your mood. It spawns two professional paths, two sets of relationships, and two futures that may eventually become as different as night and day. There is a universe where you took that job offer in another city, and one where you stayed. A universe where you mustered the courage to speak to that stranger on the bus, and one where you kept to yourself. Every possibility that flickers through your mind, every road not taken in this timeline, is a bustling, lived reality in another. This realization carries an immense psychological weight, but it's a weight of a very peculiar kind. On one hand, it offers a profound sense of freedom and the ultimate absolution from regret. The haunting question of what if loses its power. You don't have to wonder what would have happened if you had pursued a different career or said yes to a different person. In the grand tapestry of the multiverse you did. There is a version of you living out that exact alternative, experiencing its joys and its sorrows. The version of you reading this might have passed up an opportunity, but another version seized it. This can be incredibly liberating. It means that no potentiality is ever truly lost. Every talent is explored, every love is kindled, and every adventure is undertaken somewhere in the vast expanse of existence. Regret, in its traditional sense, becomes obsolete because every path is being walked. Your life is not a single, narrow thread, but an infinitely branching river flowing into every possible ocean. Yet there is a counterweight to this freedom, a potential for existential dilution. If every choice creates a new universe, then does any single choice truly matter? The significance of our decisions feels paramount in our lived experience because we are conscious of only one timeline. We agonize over choices, large and small, believing that we are shaping a singular, definitive destiny. But if a different version of us makes every possible alternative choice, then the weight of consequences spread thin across infinity. The you who makes a catastrophic mistake in this branch is balanced by the you who avoided it in another. The immense pressure to get it right vanishes, but so too might the sense of purpose that comes from navigating a unique, consequential life. Our narrative of self, the story we tell ourselves about who we are and how we got here, becomes just one volume in an infinite library. It's a story that is both endlessly validated and rendered curiously insignificant by the existence of all the other stories. This duality is the core of living in a superpositional reality. It grants us the freedom of knowing that no possibility is lost, while simultaneously challenging the very notion that our specific journey is singularly important. We are both the authors of a cherished, personal story and fleeting characters in a cosmic saga, so vast that our individual plots are indistinguishable from the background noise of creation. It asks us to hold two seemingly contradictory ideas in our minds at once, to live with the passion and intention as if this is our only chance, while resting in the comforting knowledge that, in a way, we have an infinite number of chances. So how exactly does this cosmic branching happen? What is the engine that continuously generates these new realities, ensuring that every quantum possibility gets its own stage to play on? The answer lies in a subtle but powerful process known as quantum decoherence, and it's the key mechanism that keeps these parallel worlds from tripping over each other. Think of it not as a dramatic splitting, but as a quiet fading away of connections. Imagine you're tuning an old analog radio trying to find a clear station. At one point, you land directly on a frequency and the music comes through crisp and strong. But if you turn the dial just a little, you start to hear another station faintly overlapping with the first, creating a mess of static and interference. That messy overlap is a state of quantum coherence. The different possibilities are still talking to each other, interfering with each other's signals. Now imagine turning the dial a bit more until the two stations are completely separate. Each one is now playing its own song in perfect clarity, completely unaware of the other. That separation, that loss of interference, is decoherence. It's the process that takes the fuzzy, overlapping quantum probabilities and resolves them into distinct, independent classical realities. This happens because of a simple, unavoidable fact. Nothing in the universe is ever truly isolated. A single electron in a perfect vacuum can maintain its delicate superposition, but the moment it interacts with even a single photon of light, that interaction transfers information about the electron state to the photon. That photon then flies off, carrying that information out into the environment. It's like telling a secret to one person in a crowded room. The information quickly spreads, becoming irretrievably lost in the noise of the crowd. For a large object like a cat or a person, this process happens at an unimaginable speed. Every atom in your body is constantly bumping into trillions of air molecules, being bathed in light and interacting with the gravitational field. Each of these countless interactions is a tiny measurement, a tiny act of broadcasting the state of the system into the wider world. This rapid, chaotic dissemination of information is what destroys the quantum coherence. The different potential states of the system can no longer interfere with each other because they have become entangled with different, incompatible states of the environment. They effectively lose contact with one another, becoming separate and independent. This is why we never see superpositions in our daily lives. Decoherence forces large objects to behave classically almost instantaneously. In the context of the many worlds interpretation, decoherence is the process that physically realizes the branching. It doesn't cause a single reality to be chosen. Instead, it causes the different branches of the universal wave function to dynamically separate from one another. Before a quantum event, like the decay of an atom in Schrödinger's box, the entire system, including the atom, the cat, and the box, is in a single, coherent quantum state. The alive cat and dead cat possibilities are still quantumly connected, able to influence each other. But the moment the system interacts with the environment, even in the most minor way, decoherence kicks in. The air molecules inside the box collide slightly differently with a living cat versus a dead one. The temperature is minutely different. These tiny differences are amplified as the information leaks out. The single coherent universe evolves into two effectively separate branches, each with its own version of the cat, the box, and the surrounding environment. Crucially, from the perspective of anyone or anything within a branch, it appears as though a single, definite outcome has occurred. The other branch has decoupled away, becoming inaccessible and unobservable. This gives us a powerful visual for the entire multiverse, an infinitely complex, ever-growing tree. The trunk of the tree represents the initial state of the universe at the Big Bang. Every quantum event, every possible outcome, is a fork in the branches. Our entire timeline, from the formation of our solar system to the device you're using right now, is just one impossibly slender twig on this colossal tree. Some branches are very similar to our own, diverging only on a microscopic detail a million years ago. Others are wildly different, where the laws of physics themselves may not be the same. The tree doesn't just branch on human decisions, it branches on every quantum event everywhere in the cosmos. A nuclear reaction inside a distant star going one way instead of another creates a new branch. A photon in deep space taking a left turn instead of a right creates another. The proliferation is ceaseless and mind-numbingly vast. And because decoherence ensures that these branches never interfere with each other again, each one evolves independently, a self-contained universe with its own unique history and future, forever unaware of its countless siblings growing right alongside it in the grand landscape of reality. Now, all of this is a truly captivating story, but any good scientist and any curious mind will be asking the crucial question, is there any actual proof? Can we point to a piece of data, an experiment, an observation that confirms we are living in a branching multiverse? The honest answer, at least for now, is that we lack direct slam-dunk evidence. The very nature of the many worlds interpretation makes it incredibly difficult to test. Because the different branches decohere and lose contact with each other, we, trapped in our specific branch, have no way to peek into the others. We can't receive a postcard from a universe where the Roman Empire never fell. However, the absence of direct proof is not the same as the absence of compelling reasons to take the idea seriously. The search for evidence is ongoing and takes some fascinating forms. One indirect line of support comes from the sheer explanatory power of the theory. The many worlds interpretation solves the central mystery of the measurement problem with an elegant simplicity that many physicists find appealing. It removes the need for a special, ad hoc collapse of the wave function, treating the entire universe with one consistent set of quantum rules. In this sense, its proponents argue that it is the most straightforward interpretation of the mathematics we already have. Furthermore, certain advanced experiments in quantum mechanics hint at the reality of parallel worlds, even if they don't prove it conclusively. Consider the famous double-slit experiment. When you fire particles like electrons one by one at a barrier with two slits, they create an interference pattern on the screen behind it, as if each individual electron is going through both slits at once and interfering with itself, a clear signature of superposition. Now, if you try to set up a detector to see which slit each electron actually goes through, the interference pattern vanishes. The act of measuring collapses the wave function. But in the many worlds view, the detector, the scientist, and the electron all become entangled. The interference pattern doesn't disappear, it simply splits into two branches. In one branch, the detector recorded the electron going through the left slit, and in the other, it recorded the right slit. The pattern is still there, but it's distributed across realities. While we only see one outcome, the fact that the pattern exists when we don't look is a ghostly echo of those other worlds. This leads us to one of the most startling and personal implications of this idea, the concept of quantum immortality. It's a thought experiment that pushes the logic of branching to its extreme. Imagine you are the subject in a modified version of Schrödinger's cat experiment. You're placed in a box with a device that has a 50-50 chance of releasing a deadly poison after 1 minute. You press the button and the quantum event is triggered. According to the many worlds interpretation, the universe instantly branches. In one branch, the poison is released and you die. In the other, the mechanism fails and you live. Now, from your subjective, first-person perspective, what do you experience? The argument for quantum immortality suggests that you will always find yourself in a branch where you are alive. Why? Because the version of you who dies ceases to have any conscious experience. There is no you to experience being dead. Your stream of consciousness can only continue in the branches where you survive. If you repeated this experiment 100 times from your point of view, you would miraculously survive every single time, even as countless versions of you in other branches perish. Your personal timeline would seem to be charmed, a path that somehow always avoids death. This is, of course, a deeply unsettling idea, and it's important to understand its limits. Quantum immortality doesn't mean you live forever in a youthful, healthy state. It simply means that for any lethal event that has a non-zero probability of being survived, there will be a branch where that improbable survival happens. You might find yourself in a universe where a stray bullet missed every vital organ by a millimeter, or where a terminal illness went into spontaneous remission. However, as you age, the number of branches where you are alive would dwindle. Eventually, you would find yourself in a world where you are the very last version, incredibly frail and ancient, having improbably survived every possible cause of death until finally, there are no branches left where your body can continue to function. It's a bizarre and lonely form of immortality, and most physicists see it as a logical curiosity of the theory rather than a practical reality. It highlights how our subjective experience of being a single, continuous self might be a profound illusion shaped by the branching structure of reality. While the quantum multiverse is one compelling vision, it's not the only scientific theory that suggests our universe is part of a much larger whole. Cosmology offers its own grand idea, the inflationary multiverse. This concept arises from our leading theory of the Big Bang, called cosmic inflation, which proposes that the universe underwent a brief period of exponential expansion in its first fleeting moments. Some versions of this theory suggest that this inflation didn't just happen once and stop. Instead, it may be eternal, continuing in some regions of space while ending in others. Where inflation ends, a bubble universe like our own forms, with its own local laws of physics. But the inflating space between these bubbles continues to spawn an infinite number of new bubbles forever. This cosmological multiverse is different from the quantum one. Here, the parallel universes are not branches splitting from our own timeline, but are entirely separate cosmic regions, potentially with different fundamental constants, where gravity is stronger, or the nuclear forces are weaker, or where life as we know it is impossible. They don't interact, they're simply other islands in a vast cosmic ocean. While the mechanism is different, the spirit is strikingly similar. Both theories, born from the most successful pillars of modern physics, point toward a reality that is immeasurably vaster and more diverse than our everyday perceptions could ever suggest. The fact that such a radical conclusion emerges independently from the study of the very small and the very large is, for many scientists, a powerful hint that we are on the right track. The evidence may be indirect, but the pattern is compelling. The universe seems to have a deep-seated preference for plurality, for generating endless variety. We are not the center of existence, but rather a single, fascinating expression of its infinite potential. This staggering vision of infinite branching realities forces us to confront one of the deepest and most personal questions imaginable. Who are we, really? If there are countless copies of you scattered across the multiverse, each living a different life, what binds them together as you? The concept of personal identity, something we take for granted every day, begins to unravel under the weight of this possibility. We typically define ourselves by our memories, our experiences, and the unique, continuous thread of consciousness that runs from our past to our present. But in a branching universe, that thread isn't singular. It's a rope woven from an infinite number of fibers, each leading to a different future and a different past. The version of you reading this script shares a common origin with the version who became an astronaut or the one who never left their hometown. But from the moment of the first quantum divergence, their life stories become separate and distinct. So, are they all equally you, or are they merely distant relatives who just happen to look exactly like you? This isn't just an abstract puzzle. It strikes at the very heart of what we believe makes us individuals. Consider a moment of profound choice. Imagine a version of you years ago deciding whether to move to a new country for a relationship. In this timeline, they chose to stay, building a life rooted in familiarity. In another branch, they took the leap, facing the challenges and joys of a completely different existence. For a decade, these two individuals accumulate different memories, form different relationships, and are shaped by different cultures. Their personalities, initially identical, begin to drift apart. The you who stayed might become more cautious, while the you who left develops a greater sense of adventure. After 20 years, are they still the same person? Our intuition suggests that personal identity requires more than just a shared starting point. It requires a continuous, unbroken psychological connection. The branching of the multiverse severs that connection. The other versions of you are not living your life, they are living their own. Their triumphs are not yours, and their sorrows are not your burdens to bear. This leads directly to a very practical, if surreal, question. If another version of you in a parallel universe wins the lottery, does that make you, in this universe, any richer? The answer, from a classical, common-sense perspective, is a resounding no. The money exists in their branch of reality, not yours. Your bank account remains unchanged. But this simple example reveals a deeper truth about the nature of value and experience. Value is not a quantum property that can be in superposition. It is intrinsically tied to a specific, localized conscious experience. The joy of that win, the financial security, the life-changing opportunities, all of that is confined to the conscious awareness of that specific version of you. Your consciousness, the one experiencing this reality right now, is completely isolated from that event. It's like hearing that your identical twin, whom you've never met, won a fortune. You might share DNA, but you don't share the bank balance or the lived experience. The multiverse, therefore, offers no escape from the consequences of the choices made in this branch. It provides a cosmic perspective that can absolve regret, but it does not absolve responsibility for the life you are actually living. This fragmentation of the self challenges the very foundation of individuality. We cherish the idea that we are unique, irreplaceable beings. But if every possible version of you exists, then your specific combination of traits and experiences is not unique at all. It is just one permutation in an infinite set. Your particular joys, your specific struggles, the loves that defined you, they all happen to other versions of you in slightly or vastly different ways. This can feel profoundly diminishing, as if your life's narrative is reduced to a single line in a story with an infinite number of alternate endings. The significance we attach to our singular journey seems to evaporate when every possible journey is being taken. The philosopher might ask, if everything that can happen, then does anything truly matter? Yet there is another, more empowering way to view this. Instead of diluting your identity, the multiverse could be seen as expanding it. You are not a single, lonely point. You are a vast, sprawling constellation of possibilities. Your essence is not confined to one body or one timeline, but is distributed across the cosmos. The love you feel for your family in this world is echoed in countless others, each variation adding to the richness of your total existence. Your creativity, your courage, your capacity for growth, these are not limited resources. They are explored and expressed in every conceivable context. In this light, the question shifts from who am I to what am I capable of being? the multiverse becomes a canvas for the full expression of your potential, suggesting that the concept of a single, fixed self is far too small to contain the totality of what you are. You are not less special for having doubles. You are more complex, more multifaceted, and more deeply woven into the fabric of reality than you could have ever imagined. So if the universe is truly this shimmering sea of possibilities, why on earth does the ground beneath our feet feel so unshakably solid? The answer lies not in the quantum rules themselves, but in the specific nature of our perception. We are fundamentally classical creatures living in a quantum world, and the very tools we use to experience reality, our bodies and our brains, are designed by evolution to filter out the quantum noise, leaving us with a clean, definitive, and thankfully stable picture of the world. It's a magnificent illusion crafted by the process of decoherence we discussed, but experienced intimately through the lens of our own consciousness. Think of it this way: our macroscopic size is our greatest defense against quantum weirdness. A single electron can exist in two places at once because it's incredibly small and isolated. But you are made of an astonishing number of atoms somewhere in the range of 7 octillion. Each of those atoms is constantly interacting with its neighbors, and your entire body is bathed in a storm of environmental signals, photons of light, molecules of air, the subtle pull of gravity. This ceaseless bombardment acts as a continuous, automatic measurement process. Each tiny interaction forces a local collapse, or more accurately in the many worlds view, initiates a decoherence event that separates one definite state from another. This happens on a timescale so immeasurably fast that for any object as large as a dust speck, let alone a human being, superposition is simply not a stable state. The quantum fuzziness is there, underlying everything, but it's averaged out and smoothed over by the sheer statistical weight of all your particles behaving in a largely coordinated way. Your solidity is an emergent property, a collective phenomenon that arises from the cooperative behavior of trillions upon trillions of quantum systems, all decohering together into a consistent classical reality. This leads us to the most intimate part of the puzzle, the brain itself. Your brain is not a quantum computer. It's a wet, warm, and noisy classical information processor. Its fundamental units, neurons, fire in a biochemical cascade that is far too large, hot, and disordered to maintain delicate quantum superpositions. The states that represent your thoughts, your memories, and your sense of self are classical states. They are like the bits in a computer, either on or off, not a blend of both. Your consciousness, the thing that experiences the world, appears to be built upon this classical substrate. Therefore, it is simply not equipped to perceive quantum superposition directly. It's like trying to hear a single violin note in the middle of a roaring hurricane. The signal is drowned out by the noise of your own biology. Your brain takes the messy, probabilistic input from your senses and constructs a single, coherent, and unambiguous narrative. It has to. This editing is not a flaw, it's a feature essential for survival. An organism that perceived every possible path of a predator simultaneously would be paralyzed, unable to choose a course of action. Our classical perception is a brilliant evolutionary adaptation that allows us to navigate a world where definite outcomes are necessary for survival. This creates a profound situation where the observer is, in a way, the last to know about their own quantum nature. We are like characters in a movie who believe the world on the screen is the only reality, completely unaware of the projector, the film reel, and the infinite number of other frames that could be playing. Our stream of consciousness is not a beam of light illuminating the quantum truth. It is more like a spotlight, selectively illuminating one particular branch of the multiverse and ignoring all the others. The illusion of a single timeline is so convincing because our memories are formed after decoherence has done its work. You don't remember the superposition, you only remember the definite outcome that your brain recorded. Your entire past feels fixed and unchangeable because the memory of it is a classical imprint. The branching happens in the present moment, and your consciousness simply flows along one path, its history solidifying behind it like a wake behind a ship, giving you the powerful, undeniable feeling of a single, linear life story. We are not outside the quantum system looking in. We are deeply embedded within it, and our perception is tailored to show us only one of its countless faces. But to truly grasp how these parallel worlds could remain distinct yet share a common origin, we need to explore one of quantum mechanics' most baffling and beautiful phenomena, quantum entanglement. If superposition is the idea that a particle can be in multiple states at once, entanglement is the mysterious glue that can bind those states together across unimaginable distances. Einstein famously called it spooky action at a distance, and for good reason. Imagine you have a pair of magical dice. You take them to opposite sides of the galaxy. You roll one and it comes up a 3. At that exact instant, you know with absolute certainty that the die on the other side of the galaxy has also shown a 3. This isn't a mere correlation, it's a fundamental connection that seems to transmit information faster than the speed of light, a notion that deeply troubled Einstein because it appeared to violate the laws of relativity as he understood them. In the quantum world, this happens with particles like electrons or photons. You can create a pair of entangled particles that have a shared, intertwined existence. They might be generated in a way that their spins are linked. If one is spinning up, the other must be spinning down. But here's the crucial part: until you measure one, both particles exist in a superposition of spinning up and spinning down. The act of measuring the first particle not only forces it to choose a definite state, but also instantly forces its entangled partner, no matter how far away, to snap into the opposite state. This instantaneous correlation has been proven in countless experiments, and it tells us that the universe has a deeply interconnected fabric that operates beyond our classical understanding of space and time. Now let's stretch this spooky action to its ultimate limits within the many worlds framework. If entanglement can create a link between particles across vast spatial distances, could it also create a faint, residual connection across the distances between parallel worlds? After all, when the universe branches, it doesn't create entirely new substances. It creates new configurations of the same fundamental quantum fields. The version of you in this branch and the version in another branch were once the same entity, the same collection of particles before the moment of divergence. They share an origin, and in a quantum sense, they might remain weakly entangled across the branches of reality. This opens up a truly captivating possibility for explaining some of the most elusive quirks of human experience. Consider the feeling of déjà vu, that eerie sensation that you've lived a moment before, or the sudden flash of intuition, a gut feeling that guides you without any logical explanation. What if these aren't just glitches in our neural wiring, but faint, ghostly signals from our other selves in adjacent timelines? In a universe where a decision branched your life, the version of you who took the other path might have accumulated experiences that created a subtle resonance, a quantum whisper that occasionally leaks through the barrier of decoherence. That sense of knowing someone's next words before they speak them could be a fleeting moment of synchronization with a self in a nearly identical universe who has already lived that conversation. A dream that feels more like a memory of a life you never lived could be a temporary thinning of the veil between branches, allowing a glimpse into an existence that is, in its own reality, just as tangible as your own. These wouldn't be full-blown visions or telepathic messages. The process of decoherence is incredibly effective at isolating branches, so any such connection would be extremely weak, manifesting as nothing more than a vague feeling, a hunch, or an unshakable sense of familiarity. It would be like hearing a distant radio station through static. You can't make out the song clearly, but you're aware that a signal is there. This idea transforms our understanding of consciousness from something purely localized in the brain to something that might have a subtle, non-local component, weakly entangled with its other instances across the multiverse. Our minds would not be isolated islands, but rather nodes in a vast cosmic network, occasionally picking up faint cross-talk from the other versions of ourselves, living out the infinite variations of our potential. This brings us face to face with perhaps the most disorienting consequence of all, a grand paradox that lies at the very heart of this cosmic vision. If every possible universe is equally real, then the bedrock concepts we use to navigate our lives, reality versus illusion, truth versus fiction, begin to crumble into a haze of relativity. We instinctively feel that our world is the genuine article, the solid ground of truth. But from the perspective of the multiverse, is the timeline you inhabit, the one with smartphones and space stations, any more authentic or legitimate than the one where the dinosaurs never faced an asteroid and intelligent reptiles built their own civilizations? The very idea of a singular, objective history vanishes. Every what-if story we've ever told, from the most meticulously researched alternate history to the most fantastical work of science fiction, isn't just a flight of fancy. In the infinite expanse of the multiverse, it is a documented event, a true account of a world that genuinely exists. The epic where the Roman Empire never fell, the tale where Nikola Tesla perfected his worldwide wireless energy system, the story where you became a concert pianist. These aren't mere fantasies. They are the factual histories of other branches of reality. This forces a radical redefinition of what we mean by a fact. In our daily experience, a fact is something that can be verified within our shared local reality. We agree that water is wet, that gravity pulls us down, and that World War II ended in 1945. These are the operational truths of our specific branch. But zooming out to a multiversal scale, these facts become local ordinances rather than universal laws. They are true here, but not everywhere. The laws of physics themselves might only be stable in our cosmic bubble. In another universe spawned by the inflationary multiverse, the fundamental constants could be different, allowing for utterly alien forms of matter and life that would seem like magic to us. So when we state a fact, we are really making a conditional statement. Given that we exist in this particular branch of the quantum multiverse, which resides in this specific bubble of the cosmological multiverse, where the constants of nature have these specific values, then X is true. Truth becomes contextual, tethered to your address in the greater metaverse. This perspective doesn't render our experiences meaningless. Instead, it reframes their significance. The love you feel for your family, the joy you find in your work, the challenges you overcome, these are not illusions. They are the authentic, qualitative experiences of the conscious entity that is you in this branch. Their reality is not diminished by the existence of other versions living different experiences, just as the reality of the color red is not diminished by the existence of the color blue. Your life is real because you are living it and feeling it. The illusion is not your experience itself, but the belief that your experience is the only one that counts or the only one that is fundamentally real. The grand illusion is the conviction of singularity. We are tricked by our limited perception into believing we are the center of a single-story universe, when in fact we are a single thread in an infinite tapestry. This leads to a fascinating intersection between modern physics and ancient philosophical ideas, particularly solipsism, the notion that only one's own mind is sure to exist. The many worlds interpretation presents a kind of inverted solipsism. It's not that only your mind is real, but rather that every possible mind is real. Your consciousness isn't the only genuine thing, but your perspective is unique and inescapable. You are forever bound to the subjective viewpoint of this specific branching path. You can never access the conscious experience of your other selves. You can only logically infer their existence. So, in a very real sense, your world, the one you see and feel, is the only world that will ever be directly real to you. All other branches, for all their objective reality, are as distant and inaccessible as a dream to your waking self. This creates a strange duality, a cosmic reality that is pluralistic and infinite, but a personal reality that remains stubbornly singular and immediate. We are left living in a profound tension, asked to hold two truths in our minds at once: the scientific truth of a buzzing, branching multiverse, and the phenomenological truth of our own unique, linear, and deeply personal journey. Given the reality we perceive is just one thread in an infinite tapestry, it's only natural to wonder if future technology could learn to weave with more than one thread at a time. The next frontier of innovation may not be about building better gadgets within our single reality, but about developing tools that can interact with the very structure of the multiverse itself. This would mean moving beyond using quantum effects for mere calculation and toward technologies that embrace superposition as a fundamental resource. Imagine a new class of devices, not just quantum computers, but quantum explorers, designed to navigate the branching pathways of existence. The most transformative of these might be a system with a seemingly impossible capability, a reality drive. This wouldn't be an engine for moving through space, but a hyper-advanced sensor and processor capable of maintaining a coherent quantum link across the decoherence barrier that separates parallel worlds. It wouldn't allow for physical travel, but perhaps for a form of limited observation or even communication between branches. The principle would rely on creating a perfectly isolated quantum system entangled not just across space, but across the branching points of time itself. A system so shielded from environmental noise that it could, for a fleeting moment, remain coherent with its counterpart in a nearby timeline. The most immediate application of such a profound understanding would be in the evolution of quantum computing. Today's quantum computers are incredibly fragile, their qubits losing coherence in a fraction of a second. But a mature technology built with a complete theory of universal superposition wouldn't just calculate probabilities within our world. It might perform what could be called multiversal computation. Instead of a qubit being just a 1 or a 0, it would be engineered to maintain a stable superposition that represents a direct link to its alternate states in other branches. A calculation wouldn't just explore all possible answers in theory. It could, in a sense, delegate parts of the problem to be solved in parallel realities. You could ask a question like, what is the optimal economic policy for global stability over the next century? And the computer wouldn't just simulate one path. It would tap into the actual, lived outcomes of thousands of nearly identical branches where slightly different policies were implemented, synthesizing the data into a composite answer. This wouldn't be prediction, it would be a form of cosmic data analysis, reading the results of the universe's own endless experimentation. The ethical ramifications of such a capability are staggering. Access to this kind of information would create a divide far greater than any socioeconomic gap we have today. It would be the ultimate insider trading, a way to know the outcome of every business venture, every political campaign, and every scientific experiment before it even begins. A society with a functioning reality drive would face profound questions about free will and destiny. If you could peek into a branch where a specific decision leads to catastrophe, would you be morally obligated to avoid that path? And if you do, are you truly making a choice or just following a script written by a machine that has already seen the ending? The very concept of progress could change. Scientific discovery might slow to a crawl, not from a lack of curiosity, but because researchers could simply query the multiverse for the outcomes of experiments they haven't even designed yet, potentially robbing humanity of the iterative process of trial and error that often leads to deeper understanding. Perhaps the most haunting application of this technology would be personal. Imagine a device that could allow you to communicate in a very limited way with other versions of yourself. It wouldn't be a telephone call across dimensions, but more like exchanging brief, structured messages, a cosmic pen pal system with your own soul. You could ask the version of you who moved to a different country, was it worth it? Or consult the you who pursued a different career, what did I miss? The potential for closure and personal growth is immense, offering a definitive answer to every what if that has ever kept you awake at night. Yet, the psychological impact could be devastating. Learning that a version of you is living your dream life could breed profound dissatisfaction and resentment toward the choices that shaped your own path. It might lead to a condition we could call branch envy, a deep existential sadness born from the constant, irrefutable awareness of all the lives you are not living. The technology meant to satisfy our deepest curiosity could instead become a source of perpetual torment, forever reminding us that for every joy we experience, there is a version of us experiencing a different one. This concept leads us to a truly profound and deeply personal implication, one that touches the very core of who we are, the nature of our own private thoughts. We all have an inner world, a space of secret hopes, unspoken fears, and desires we would never act upon. We assume these are locked away safely in the privacy of our own minds, known only to us. But in a universe of endless branching, this privacy may be the ultimate illusion. Every thought that flickers through your consciousness, every impulse you quickly suppress, every path you consider but ultimately reject doesn't just vanish. In the grand quantum tapestry, it becomes a reality. The version of you who did act on that impulsive thought, who voiced that harsh criticism, or who pursued that forbidden desire, is living a full and complete life in a parallel world. Your most intimate self is not a secret at all. It is a public spectacle playing out across the multiverse. This completely reshapes our understanding of guilt and personal responsibility. Consider a moment of anger where you have a fleeting, violent thought, but you immediately master it and respond with patience. In our classical view, you are a good person for exercising self-control. The thought remains private and the action defines your character, but in the branching universe, that suppressed impulse is not suppressed at all. It is the founding moment of an entire timeline. There is a world where that version of you followed through, with all the ensuing consequences and regrets. So, where does the true you reside? Are you the collection of actions you take in this branch, or are you the sum total of every possible action taken by every version of you? This doesn't invalidate the moral weight of your choices in this life. Your actions here still have very real consequences for you and those around you in this timeline. But it does suggest that our inner turmoil, the struggle between our better angels and our darker impulses, is not just a psychological battle. It is a literal, physical fracturing of our being into multiple existence paths. The guilt you might feel over a mere thought could be an eerie, subconscious resonance with the tangible guilt your other self is experiencing in their world. The idea extends to our very identity. We often think of ourselves as having a single, core personality, but the reality may be that we are a superposition of personas. The introverted you who prefers a quiet night at home is just as real as the extroverted version of you who is the life of the party in another branch. The courageous you who speaks truth to power exists alongside the cautious you who remains silent. These aren't just potential facets of a single identity, they are fully realized individuals living separate lives. This means that the concept of a true self becomes incredibly fluid. There is no one authentic version of you waiting to be discovered. Instead, you are a spectrum of selves, and the person you are in this moment is simply the one that has been actualized by the specific chain of quantum events that constitute your timeline. Your deepest secrets aren't secrets you're keeping from the world. They are entire lifetimes being lived by your other selves, forever hidden from you, yet fundamentally a part of your total existence. So how would this radical perspective reshape our daily lives, particularly our relentless pursuit of success and our deep-seated fear of failure? If every path is being walked somewhere, the very definitions of winning and losing begin to blur into something far more fluid. Our culture is built on a linear model of achievement, a ladder we're all trying to climb, where a single misstep can feel like a permanent fall. But in a multiverse, there is no single ladder. There is an infinite jungle gym, and every swing, every leap, and every apparent fall simply lands you on a different part of the structure, opening up a new set of possibilities. The crushing weight of a failed business venture in this timeline is balanced by the soaring success of that same venture in another. This isn't meant to trivialize the very real disappointment you feel, but to reframe it. Your failure isn't an endpoint, it's a data point. It's one outcome in a cosmic experiment, and the version of you in the next branch is already learning from it and applying those lessons to a different endeavor. This could lead to a profound liberation from the fear that so often paralyzes us. The anxiety about choosing the right career, the right partner, or the right city to live in melts away when you internalize that there is no single right answer. Every choice creates a new adventure. Imagine approaching your life with the mindset of a scientist running experiments. A scientist isn't devastated when a hypothesis is proven wrong. That result is valuable information that guides the next experiment. In the same way, taking a risk starting that creative project, asking for that promotion, learning a new skill isn't a gamble with your entire future on the line. It's an investigation into one possible version of your life. If it doesn't work out as hoped, you haven't ruined your life. You've simply collected crucial data about what doesn't work for you in this particular branch of reality. Information that can make your next experiment more focused and effective. This encourages a culture of bold experimentation, where the stigma of failure is replaced by the value of learning. This shift could fundamentally alter our relationship with comparison and envy, two of the greatest sources of modern unhappiness. Scrolling through social media, we are bombarded with curated highlights from other people's lives, leading to the nagging feeling that we are falling behind. But in a multiversal view, you are not competing with anyone, not even yourself. The friend who seems to have it all together is simply living out their path in their branch. Your journey is uniquely yours, and its value isn't determined by how it stacks up against others, but by the richness of the experiences it contains. Even more powerfully, the envy you might feel towards a more successful version of a peer is, in a cosmic sense, envy directed at another version of yourself. The drive to achieve could transform from a need to outpace others into a desire to explore the full spectrum of your own potential, celebrating the successes of your other selves as proof of what is possible, rather than as a measure of your own inadequacy. Ultimately, this perspective invites us to trade a mindset of scarcity for one of abundance. We often operate from a place of lack, believing there are limited spots for happiness, success, and love. This creates a frantic, grasping energy, but if every possibility is actualized, the cosmos is the ultimate expression of abundance. There is no shortage of joy, no limit on achievement, because it is all happening everywhere. This doesn't promote laziness. Instead, it cultivates a deep-seated security. Knowing that your potential is infinite can free you to focus on the quality of your journey in this specific reality, to be fully present in the life you are actually living. You can pursue goals with passion and purpose, not because you need to win to be valid, but because the act of pursuing itself is a magnificent expression of your existence. Success becomes less about reaching a specific destination and more about the courage to explore the vast and wondrous landscape of your own becoming. This expansion of the self into a myriad of parallel existences forces us to confront one of the most difficult philosophical challenges imaginable, the nature of moral responsibility. Our entire system of ethics and law is built on the bedrock of individual agency, the idea that you are accountable for the choices you make. But what happens to that accountability when every possible choice is made by some version of you? If a version of you in a neighboring timeline commits a horrific act, a crime that would land you in prison for life in this world, where does the guilt lie? Are you, the version reading this, in any way culpable for the actions of a self you can never meet or influence? This question stretches our concepts of justice and morality to a breaking point, suggesting that good and evil might not be absolute, but relative to the specific circumstances of a given timeline. To untangle this, we need to examine the very foundations of moral responsibility. We typically hold someone accountable based on a few key factors: their intentions, their knowledge of the act's consequences, and crucially, their capacity to have chosen otherwise. In our classical world, when you choose to help an elderly person cross the street, you are praised for your kindness because you could have chosen to walk on by. Conversely, if you choose to steal, you are condemned because you had the free will to not steal. Your moral character is judged by the decisions you actually make from a menu of possibilities. But in the multiverse, this framework collapses. The version of you who committed the theft did not have the free will to choose otherwise in that specific branch. The quantum dice fell in a way that made that action inevitable within that reality's causal chain. Meanwhile, the you in this branch who would never dream of stealing also had no choice in the matter. Your path was equally determined by the branching event. If neither of you could have acted differently in your respective worlds, then the very premise of praise and blame seems to vanish. This leads to a terrifying form of moral dilution. If every conceivable action is performed by some instance of you, then are you truly a moral agent or merely a passive witness to a script written by quantum probability? It creates a kind of ethical vertigo where the sharp lines between right and wrong begin to blur into a fog of relativism. The saint and the serial killer are both expressions of your potential. This doesn't mean that actions lose their local consequences in the branch where the crime occurs. Victims still suffer and society still demands justice. But it does challenge the idea of a unified, singular self that can be held ultimately responsible. Your moral essence becomes distributed, like a single light source shattered into a spectrum of colors by a prism. You are not purely good or purely evil. You are a superposition of moral states, with each branch actualizing a different shade of your character. Yet there is a compelling counterargument that emerges from this very distribution. While you may not be directly responsible for the actions of your other selves, you might bear a different kind of responsibility, a responsibility for your potential. The fact that a version of you exists who is capable of a heinous act indicates that the raw material for that darkness exists within the broader quantum construct of you. It wasn't an alien impulse. It emerged from a psychological framework that, under a specific and perhaps terrible set of circumstances, produced that outcome. This shifts the focus of morality from judging single actions to cultivating character. The ethical imperative, then, becomes a lifelong project of strengthening the aspects of your character that lead to virtuous outcomes across the majority of branches. By consciously choosing compassion over anger, patience over impulsivity in this timeline, you are not just making one good choice, you are reinforcing a psychological pattern that likely leads to better outcomes in a vast number of parallel worlds. Your moral effort in this branch has a resonant effect, increasing the statistical weight of positive outcomes across the multiverse. This perspective could radically transform our justice systems. A court of law in a single branch would, of course, still need to deal with the version of an individual who committed a crime within that specific reality. But a society aware of the multiverse might view rehabilitation not just as fixing one broken person, but as adjusting the underlying psychological and social conditions that lead to criminality across countless branches. Punishment purely for retribution would seem increasingly primitive. If the criminal sitting in the dock is just one manifestation of a person who, in other worlds, is a law-abiding citizen, then the goal shifts from vengeance to understanding and correcting the systemic or personal failures that caused this particular branch to diverge into tragedy. Justice becomes less about punishing a rogue self and more about healing the fractured whole. Ultimately, the concept of a branching multiverse does not destroy morality. It complexifies it beyond our current comprehension. It asks us to hold two seemingly contradictory ideas in our minds. First, that we must live with absolute seriousness and intention in this branch, making the best choices we can and fully owning their consequences here and now. And second, that we must cultivate a profound humility, recognizing that our specific moral certainty is a product of our unique path, and that other versions of us are living with their own, equally valid from their perspective, certainties. Ethics in an infinite universe becomes a balance between fierce local responsibility and a cosmic, compassionate perspective that recognizes every soul, even the darkest versions of ourselves, as walking a path shaped by forces both within and beyond their control. Given the sheer effectiveness of decoherence at isolating us within our own reality, the notion of ever catching a glimpse of another branch might seem utterly impossible. Yet, the human experience is filled with strange, fleeting moments that defy easy explanation, sudden feelings of déjà vu, unexplained premonitions that come true, or bizarre coincidences that feel too meaningful to be random chance. Could these be more than just neurological glitches? Could they be rare, momentary failures in the barrier between worlds, allowing a subtle leakage of information from a neighboring timeline? While firmly in the realm of speculation, some theoretical frameworks allow us to explore this tantalizing possibility. One such idea involves pushing the concept of quantum tunneling to its absolute limit. We know that particles can sometimes tunnel through energy barriers they classically shouldn't be able to overcome. If consciousness itself has a quantum component, however subtle, perhaps under extraordinary circumstances, a person's awareness could momentarily tunnel across the decoherence barrier that separates branches. This wouldn't be a physical journey, but a temporary alignment or resonance with the conscious state of another version of yourself. The experience would likely be chaotic and incomprehensible, a jumble of foreign memories, emotions, and sensations that fade as quickly as they appear, leaving behind only a profound sense of strangeness. These theoretical leaks might manifest in the phenomena we often dismiss as quirks of the mind. Consider a vivid dream that feels less like a fantasy and more like a memory of a life you never lived. You wake up with a distinct feeling of having said goodbye to someone you love, or of walking through a city you've never visited, yet every detail feels concrete and real. In a multiverse, this might not be your imagination at all. It could be a brief, spontaneous synchronization with the ongoing experiences of your other self in a closely related branch. Similarly, a powerful premonition, a gut feeling that you should avoid a certain flight, which later turns out to have been cancelled or met with disaster, might be explained not as psychic ability, but as your subconscious mind picking up on the data of a nearby timeline where the event has already occurred. The version of you in that branch experienced the outcome, and through a crack in the wall between realities, that information faintly echoes into your awareness, guiding your actions without your conscious understanding. Even the common experience of synchronicity, those meaningful coincidences where an internal thought seems to manifest instantly in the external world, could be reinterpreted. You think of an old friend you haven't seen in years, and moments later, you randomly bump into them on a street in a different city. From a classical perspective, it's a 1 in a million chance. But from a multiversal viewpoint, it might be a temporary convergence of branches. Your thought of the friend and the actual encounter are two events that are causally connected in many timelines. For a fleeting instant, the probability waves of those two closely aligned realities might have constructively interfered, strengthening their connection just enough to make the seemingly impossible encounter a reality in your world. It would be like two radio stations on nearly identical frequencies briefly overlapping to create a clear, unified signal before drifting apart again. The most dramatic potential evidence could be what people call glitches in the matrix, those jarring instances where reality seems to stutter. Our object appears to be in one place, then suddenly in another with no logical explanation. Or you have a clear, shared memory of an event with someone else that contradicts the established historical record. While often attributed to false memories or perceptual errors, these events could be conceptualized as a more significant, localized failure of decoherence. Imagine if a specific location, through some unknown geological or energetic anomaly, acted as a weak spot in the fabric of reality. In such a place, the isolation between branches might be thinner, allowing for a more tangible bleed through. You might catch a ghostly, half-second glimpse of a building that isn't there, or hear a conversation from a timeline where the surrounding environment developed differently. These wouldn't be hallucinations, they would be genuine, though incredibly rare, perceptual leaks from parallel worlds. Ultimately, the search for coherence, for a conscious connection to the multiverse, remains one of the most fascinating frontiers of this idea. It suggests that our minds might not be entirely closed systems, but rather possess a latent and almost always dormant sensitivity to the broader quantum reality in which we are embedded. While we are fundamentally designed by evolution to perceive a single, stable world, the underlying quantum truth might occasionally and mysteriously shimmer through the cracks of our perception, offering us fleeting, bewildering hints that our story is far from the only one being told. But this leads us to perhaps the most profound and dizzying application of the idea yet. We've applied the logic of superposition to cats and to ourselves, but what if we were to scale it up to the ultimate level? What if we placed the entire universe inside Schrödinger's box? This isn't just a playful metaphor, it's a serious question that emerges from our deepest cosmological theories. Could the cosmos itself be in a state of superposition, hovering between existence and non-existence? The key to this staggering possibility lies in our understanding of how everything began. The prevailing scientific narrative is the Big Bang, a colossal explosion of space and time from an infinitely dense point. But what caused that initial singularity? What set it off? Many physicists point to a purely quantum origin. In the void of what we might call nothingness, empty space is not truly empty. Due to the uncertainty principle, it's a seething foam of virtual particles, constantly flickering in and out of existence in a dance of quantum fluctuation. These are tiny, temporary borrowings of energy that quickly cancel themselves out. But what if, on a scale beyond comprehension, a fluctuation didn't cancel out? What if a quantum wobble in the fabric of nothingness was so vast that it burst forth, inflating at an unimaginable rate to become the entire universe we see today? In this view, our cosmos isn't the inevitable result of a cosmic clockwork. It is a single, spectacular possibility that somehow gained reality from an infinite sea of potential. This transforms the nature of our existence into something far more mysterious and precarious. If our universe began as a quantum fluctuation, then before that moment, it existed in a state of pure potential. It was both existent and non-existent, a possibility waiting to be actualized. The moment of the Big Bang, then, could be seen as the universe's own wave function collapse, the instant it was observed into being. But observed by what? This is the cosmic version of the observer problem. In the absence of any external observer, since by definition there is nothing outside the universe, what forced this particular possibility to become real? One answer following the von Neumann-Wigner idea is almost theological, that a universal consciousness was required to bring the cosmos into being. Another, more naturalistic answer comes from the many worlds interpretation. It suggests that there was no collapse at all. the quantum fluctuation that became our universe was simply one outcome. In other branches of a greater multiverse, other fluctuations became entirely different universes, each with its own unique laws of physics. And in an infinite number of other branches, no fluctuation ever achieved critical mass and nothingness reigns eternal. Our universe, in this grand view, is not special or necessary. It is simply one outcome that happened to produce beings like us who can wonder at its existence. This idea finds a haunting parallel in the concept of a false vacuum. Our universe seems stable, but some theories suggest this stability might be an illusion. We may exist in a false vacuum state, a valley of low energy that seems permanent but is actually metastable. A truer, lower energy vacuum could exist. If our universe were to somehow tunnel into that true vacuum state, perhaps triggered by a high energy event, it would unleash a cataclysm that would rewrite the laws of physics at the speed of light, obliterating everything we know. Until that unlikely event occurs, our universe is in a superposition of being stable and being catastrophically unstable. It is both the safe harbor we perceive and a potential bubble of nothingness waiting to pop. This cosmic precariousness mirrors the state of the cat alive in its current stable state, but with the potential for instantaneous death lurking within its very fabric. We are living in a universe that is, on a fundamental level, both here and not here, permanent and temporary, a definitive reality and a fleeting quantum mayfly. Our entire cosmic history, from the first stars to the civilizations that now gaze upon them, would then be just one delicate thread in a tapestry of possibilities, a single, breathtaking answer to a question that the void never stops asking. But perhaps this mind-bending view of a quantum reality has an even more startling explanation, one that bridges the gap between the deepest laws of physics and one of the most popular futuristic theories of our time, the simulation hypothesis. What if the reason our universe seems to operate on probabilities is because it is, in fact, a vast computational system? The simulation argument, famously explored by philosophers like Nick Bostrom, suggests that if advanced civilizations can create realistic simulated worlds, then the number of simulated beings would vastly outnumber the real ones, making it statistically likely that we are in a simulation. When we layer the principles of quantum mechanics onto this idea, we get a fascinating and efficient design for how such a simulation might actually work. Instead of painstakingly rendering a single, predetermined universe from start to finish, a super-intelligent simulator would find it far more elegant and resource-effective to build a cosmos that runs on quantum rules. In this digital framework, superposition isn't a bug, it's the ultimate feature. Think about the immense computational power required to simulate a universe down to the last atom in a single, linear timeline. Every event would have to be calculated in a strict cause and effect chain, a monumental processing task. Now, consider a more efficient model, a system that doesn't calculate one definitive outcome, but instead calculates the wave function, the full spectrum of all possible outcomes, and only resolves them into a specific reality when absolutely necessary. This is the quantum way. It's the difference between a computer rendering a pre-scripted movie and a computer running a sophisticated, open-ended video game. The game engine doesn't pre-render every possible action a player might take. That would be impossibly wasteful. Instead, it has a set of rules, a physics engine, and it generates the world locally and on the fly as the player interacts with it. In our cosmic simulation, the quantum wave function is the ultimate physics engine, and the act of observation, the interaction between systems, is the trigger that forces the graphics card, so to speak, to render a definite scene. This perspective turns the Schrödinger's cat paradox from a philosophical puzzle into a clever programming shortcut. From the simulator's point of view, it's computationally cheap to maintain the cat in a mixed state of alive and dead. It simply keeps two sets of variables in a state of unresolved potential. The expensive part is rendering the full, consistent reality for an observer. So, the simulation conserves resources by only doing that detailed rendering at the moment the box is opened. At that point, it doesn't delete the other possibility, it simply branches the processing. One thread continues calculating the universe where the cat is alive, complete with the relieved experimenter, while another, separate thread handles the universe with the dead cat and the sad scientist. This is eerily similar to the many worlds interpretation, but with a tangible mechanism, the parallel processing of a supremely advanced computer. We, as conscious entities within the simulation, wouldn't perceive the branching. Our awareness would be confined to a single processing thread, experiencing it as the one and only reality. The implications for free will within this digital superposition are profound. If the simulation is calculating all possibilities, then our sense of making choices is authentic. We are not following a predetermined script. The simulator isn't deciding that you will choose coffee over tea. It's simply equipped to handle both outcomes. Your deliberation is real, and the branching of the timeline that results from your decision is a consequence of the simulation's architecture, which is built to accommodate genuine agency. Your life feels unpredictable and open-ended because, from the perspective of the underlying code, it genuinely is. The simulation doesn't know what you will choose, it's just ready for whatever you do. This makes our experienced reality not a pale shadow of a real world, but a rich, dynamic, and computationally feasible way to create a universe of endless variety and exploration. In this light, the quantum superposition that underpins everything might be the most elegant signature of a creator who values possibility above all else. For thousands of years, long before physicists ever conceived of a wave function, mystics and spiritual seekers have described experiences that sound remarkably like a brush with the quantum world. Through deep meditation, intense prayer, or the use of sacred plants, individuals report a dissolution of the hard boundaries of the self, a feeling of merging with the cosmos, and a perception of reality as a fluid, interconnected whole. It's a description that stands in stark contrast to our normal, classically minded consciousness, which is so effective at carving the world into distinct, separate objects. This raises a provocative possibility. Could these altered states of consciousness be a form of temporary, biological hacking of the decoherence process? Perhaps the constant mental chatter and sensory input that define our waking lives act as a kind of internal measurement device, continuously collapsing our personal wave function into a single, linear reality. Practices that quiet this noise might, in theory, allow the underlying quantum nature of our minds to seep into our awareness. Think of your everyday mind as a highly polished mirror, perfectly reflecting a clear and stable image of the world. This mirror is your survival tool, and its clarity depends on the brain filtering out an immense amount of information. But what if certain practices could tarnish that mirror's surface or even crack it slightly? Deep meditation aims to do just that by focusing on the breath or a mantra. The meditator learns to observe thoughts and sensations without getting caught up in them. This gradual quieting of the brain's default mode network, the area associated with our sense of a continuous narrative self, might reduce the internal observation that reinforces our classical reality. In this state of heightened awareness and reduced ego, the sharp lines between observer and observed begin to blur. The meditator might not see a literal superposition, but they might experience a profound sense of unity, where the distinction between their own consciousness and the room around them softens, hinting at the underlying interconnectedness that quantum entanglement suggests is fundamental. Psychedelic substances like psilocybin or LSD offer an even more dramatic, if less controlled, pathway to this softened perception. These compounds chemically alter the brain's filtering mechanisms, allowing a flood of sensory and cognitive information that is normally suppressed. The result is often a spectacular breakdown of classical boundaries. Visual trails where a moving object appears to exist in multiple places at once are a common effect. While this is a neurological phenomenon, it serves as a powerful metaphor for perceiving multiple states simultaneously. More profoundly, users frequently report ego dissolution, the complete loss of the sense of a separate self. This experience, often described as becoming one with everything, mirrors the quantum idea that at the most fundamental level, separateness is an illusion arising from decoherence. In the psychedelic state, the measurement that constantly reaffirms your individuality may be temporarily suspended, allowing a direct, overwhelming experience of the unified field from which all possibilities arise. Of course, we must be cautious not to conflate metaphor with mechanism. A mystic's vision or a psychedelic trip is not proof of quantum superposition in the brain. The brain is likely too warm and wet to maintain large-scale quantum coherence for any significant time. However, the intriguing link may not be that the brain is a quantum computer, but that its normal, classical operating mode is brilliantly designed to hide the quantum world from us. Altered states could simply be disabling this evolutionary adaptation, giving us a raw, unfiltered glimpse of the chaos and interconnectedness that lies beneath our polished reality. It's as if we've spent our lives looking at a finished painting, but for a moment we are allowed to see the countless brushstrokes, the mixing of colors on the palette, and the infinite possibilities that existed before the artist made each definitive choice. This perspective beautifully bridges ancient wisdom and modern science, suggesting that the unity described by saints and the non-locality described by physicists are two different languages pointing toward the same profound truth about the nature of existence. Now let's project this vision into an almost unimaginable future, a time when humanity has not merely understood the quantum world but has learned to inhabit it consciously. Generations from now, our descendants may evolve beyond the biological and technological constraints that currently bind us to a single reality. In this speculative era, human consciousness could undergo a profound transformation, achieving a state where navigating the branches of the multiverse becomes as natural as breathing is to us today. This wouldn't be about building machines to observe other timelines. It would be about evolving the self to experience them directly. The ultimate goal of such an evolution would be to become what we might call quantum beings, entities whose awareness is no longer confined to a single, linear stream of experience, but can flow like a river delta into multiple channels at once. Life would cease to be a singular narrative and would instead become a symphony of parallel experiences, each one contributing to a richer, more complex understanding of existence. Imagine a form of existence where a major life decision, like choosing a career path or a life partner, is no longer an either-or dilemma. A quantum being could consciously split their focus, allowing one thread of awareness to pursue the life of an artist in one timeline, while another thread lives the life of a scientist in a neighboring branch. This wouldn't create a schizophrenic fragmentation, but a harmonious expansion of the self. Through advanced neural interfaces or pure mental discipline, the core consciousness would maintain a meta-awareness, a sense of being the central node that observes and integrates the experiences of all its branches. The joy of a discovery in the science branch and the satisfaction of completing a masterpiece in the art branch would both feed back into a unified sense of personal growth. Regret would become an obsolete emotion, not because choices don't matter, but because every choice is fully explored. The feeling of loss from a path not taken would be replaced by the direct knowledge of what that path actually held. The technology enabling this would likely be a fusion of unimaginably advanced biotechnology and quantum information systems. We might develop a quantum cortex, an additional layer to our brain that can entangle with the fundamental quantum fields underlying spacetime. This organ wouldn't just think, it would resonate with possibility. It would allow an individual to sense the probability landscapes of nearby timelines and willfully guide their consciousness to tune in to a desired branch. This conscious branching would be the ultimate expression of free will. Instead of being a passive passenger on a single track, you would become an active pilot, choosing which potential versions of your future to make real from your own first-person perspective. Your life's journey would transform from following a set of railroad tracks to navigating a vast, open ocean of possibilities. Yet, with this incredible power would come profound new challenges and ethical dilemmas. What happens to relationships in a world of conscious branching? If one partner in a relationship chooses to branch into a timeline where they pursue a solitary life of exploration, does that constitute a form of abandonment for the partner who remains in the original branch? Would quantum societies develop new forms of marriage or partnership contracts that account for multidimensional existence? Furthermore, the concept of individuality would be utterly transformed. If you can regularly merge your awareness with the experiences of your other selves, absorbing their memories and insights, where does one person end and another begin? The very definition of a person might expand to encompass a collective of closely related consciousnesses, a tribe of self sharing a common origin but exploring existence in diverse ways. This could lead to a society based not on the individual but on the quantum clan, a group of branched selves working together as a single, multifaceted entity. The ultimate goal of such an evolution might be to achieve a state of quantum synthesis or harmony. After eons of exploring infinite branches, a mature quantum consciousness might seek not just to experience possibilities, but to integrate them into a coherent whole. This could be seen as the reverse of branching, a conscious merging of timelines. A being that has lived as 1,000 different versions of itself might eventually learn to hold all those experiences simultaneously in a single, transcendent state of awareness. This wouldn't be a collapse back into a single point, but an expansion into a higher dimensional perspective where all paths are seen as interconnected threads in a grand tapestry. From this vantage point, the distinction between self and other, between one timeline and the next, might dissolve entirely, leading to a state of unity with the cosmos that mystics throughout history have only ever glimpsed. In this far future, humanity's journey would culminate in becoming not just observers of the quantum universe, but active, conscious participants in its endless, beautiful unfolding. This quantum perspective on reality doesn't just reshape our future, it invites us to take a second look at our past, to revisit the historical puzzles that have stubbornly resisted explanation. For centuries, archaeologists and historians have been confronted by anomalies, artifacts that don't belong, stories that seem too fantastical to be true, and entire civilizations that vanished with barely a trace. What if these aren't mere gaps in our knowledge, but faint ripples lapping at the shore of our timeline from parallel histories? The idea that our universe might be porous, allowing for subtle leaks of information or even matter from adjacent branches, offers a thrilling science fiction-infused key to unlocking some of humanity's greatest enigmas. Consider the famous case of the Antikythera mechanism, an ancient Greek device of breathtaking complexity, often described as the world's first analog computer. Found in a shipwreck, it contains a labyrinth of precise bronze gears that could predict planetary movements and eclipses. Its sophistication is so far ahead of anything else from its time that it feels like an artifact out of place. The conventional view is that it was a remarkable but isolated invention, its knowledge lost to history. But through a quantum lens, another possibility emerges. What if the Antikythera mechanism is not an anomaly in our timeline, but a piece of technology that properly belongs to a nearby branch? Perhaps in a parallel world, the Hellenistic world experienced a continuous scientific revolution, and this device was commonplace. A chance quantum fluctuation, a moment of weakened decoherence at the site of the shipwreck, could have allowed this object to briefly tunnel or cross over into our history. It would be a piece of a neighboring reality that somehow became entangled with our own, leaving behind a tantalizing clue of a road not taken by our civilization. This same logic could be applied to the mythologies and oral histories that have been passed down for generations, often dismissed as mere legend. Stories of great floods, of advanced ancient civilizations like Atlantis or Mu, could be more than just allegory. They might be cultural memories, deeply ingrained and passed down, of actual historical events that occurred in a closely aligned branch of reality. Imagine a timeline where a catastrophic asteroid impact 12,000 years ago was not a near miss but a direct hit, wiping out a nascent advanced culture. The survivors of that event, living in the branch where the impact was less severe, might have carried with them fragmented, terror-filled stories of the complete destruction they witnessed in the other reality. Over millennia, these stories would morph into myth, but their core, the tale of a great civilization sunk beneath the waves, would persist as a ghostly echo of a tragedy that fully unfolded in a world next door. Even the baffling disappearance of entire populations, like the colonists of Roanoke or the sophisticated society of the Maya, takes on a new dimension. The prevailing theories involve drought, war, or integration with other groups. But what if the answer was more literal? What if a large group of people didn't just move away, but actually faded into another probability stream? A localized, massive quantum event, perhaps triggered by unique geological or atmospheric conditions, could have caused a temporary but large-scale merger of timelines. The missing population may have seamlessly transitioned into a nearly identical branch, continuing their lives there, while from our perspective, they simply vanished without a trace. They would have left behind only empty settlements, creating a mystery that is unsolvable if we only look for answers within the confines of a single, fixed history. Their fate wasn't death or migration, but a cosmic relocation. This framework also provides a fascinating new way to interpret coincidences that feel too meaningful to be random. The phenomenon of multiple discovery, where two or more scientists in different parts of the world make the same breakthrough independently at almost the same time, like Newton and Leibniz with calculus, is often put down to the zeitgeist, the spirit of the age. But what if it's a form of low-level cognitive entanglement? The intense focus of brilliant minds on the same problem in different branches might create a resonance, a subtle leakage of insight across the decoherence barrier. The solution doesn't just emerge from the intellectual environment of one world, but pools into several closely related timelines simultaneously, as if the idea itself is reaching a critical mass across the multiverse. This would mean that great discoveries are not just inventions of a single mind, but are phenomena whose time has come across a swath of parallel existences. While this is a speculative leap, it demonstrates the power of a quantum perspective to breathe new life into old mysteries. It encourages a form of historical thinking that is less about filling in a single, linear narrative and more about mapping a vast, interconnected web of potential past. The anomalies that dot our history are no longer inconvenient errors to be explained away. They become potential windows, fleeting glimpses into the infinite library of what could have been. They suggest that our past is not a closed book, but a story that is still subtly intertwined with all the other stories the universe is telling simultaneously. Of course, such a mind-bending vision of reality doesn't come without its own set of formidable challenges. For all its elegance in solving the measurement problem, the many worlds interpretation forces us to confront some deeply counterintuitive and, for many, deeply unsatisfying consequences. Perhaps the most immediate objection is what it does to our understanding of probability. In our everyday lives and in standard quantum mechanics, we talk about chances. We say an electron has a 50% probability of being spin up and a 50% chance of being spin down. This language of likelihood is the bedrock of how we predict outcomes, from radioactive decay to the weather. But if the many worlds view is correct and both outcomes definitively happen, then what does it even mean to say one outcome is more or less probable? Probability seems to vanish, replaced by a simple accounting of outcomes. every possible event, no matter how astronomically unlikely, occurs in some branch. So, why does it feel so much more likely that we'll find Schrödinger's cat alive if the poison has only a 1% chance of being released? If both the live cat and dead cat worlds are equally real, why does the 50-50 split feel any different from a 99-to-1 split? Proponents of many worlds have a sophisticated, if subtle, answer to this. They argue that probability doesn't describe the chance of an event happening, but rather the subjective chance of you ending up in a branch where that event happens. It's about self-location. Imagine a lottery with 1,000,000 tickets. In a single worldview, you have a 1 in 1,000,000 chance to win. In the many worlds view, there are 1,000,000 branches, one for each winning ticket. You buy a ticket in each one, but from your perspective before the draw, you don't know which branch you will find yourself in after the results are announced. The number of branches corresponding to a particular outcome, weighted by the amplitude of the wave function, determines your subjective expectation. So, a 50-50 split means there are vastly more branches where you see a result close to that ratio, making it your expected experience. It's a shift from objective chance to a measure of your future personal experience across the multiverse. While logically consistent, this explanation can feel like a workaround, replacing the intuitive idea of chance with a complex metric of branching selves. A second, more visceral criticism is the sheer, grotesque extravagance of the theory. Occam's razor, the principle that we should favor the simplest explanation that fits the evidence, seems to be brutally violated. What could be more extravagant than proposing an infinite, and indeed an exponentially increasing, number of entire universes to explain the fuzzy behavior of a single electron? Critics argue that postulating a new universe for every quantum event is the intellectual equivalent of using a supercomputer to crack a nut. The Copenhagen interpretation, for all its mysterious collapse, at least keeps reality contained. It says the other possibilities were never real to begin with, they were just potential. Many worlds, by making them all real, posits a reality of unimaginable bulk and complexity. Defenders fire back that their interpretation is actually more parsimonious because it removes the need for an extra, ad hoc rule, the wave function collapse. They argue that the multiplicity of worlds is not an assumption but a consequence of taking the straightforward math of quantum mechanics at face value. The extravagance, they say, is already in the equations. It's our classical intuition that is struggling to keep up. The real violation of Occam's razor, in their view, is adding the unnecessary and ill-defined process of collapse. This leads to a more philosophical unease, the problem of empirical testing. A good scientific theory is supposed to make predictions that can be falsified by experiment. But if the other branches are permanently inaccessible due to decoherence, how can we ever prove they are there? Any experiment we conduct, any observation we make, will inevitably place us in a branch consistent with that result. We can never step outside the system to see the whole branching tree. This means the many worlds interpretation may be untestable in principle. It makes the same experimental predictions as other interpretations, like the Copenhagen view. This places it in a strange category. It might be a true description of reality, but one that is fundamentally beyond the reach of scientific verification. For many scientists, this is a major weakness, pushing the theory toward the realm of metaphysics rather than empirical science. It becomes a matter of philosophical taste. Do you prefer a reality with a mysterious collapse or a reality with infinite, unobservable copies? Finally, there is the unsettling question of identity we touched on earlier, which becomes a powerful philosophical counterargument. If every decision branches a new version of me, then the I that is writing this sentence is just one among an infinity. The connection between my past self and my future self becomes tenuous. If I choose to have coffee tomorrow, the me that drinks tea is a completely separate individual. This challenges our deepest sense of continuous selfhood. If my consciousness is just a momentary flicker on one branch of a cosmic probability tree, what meaning does my life have? The theory can feel existentially nihilistic, suggesting that our struggles, our loves, and our achievements are just one variation in an endless cacophony, rendered insignificant by their infinite repetition. While the theory offers freedom from regret, it can also steal away a sense of unique purpose. Our narrative of self, the story we tell ourselves about our lives, may be the most profound casualty of the many worlds interpretation, leaving us as transient patterns in an infinite and indifferent multiverse. We have traveled a remarkable distance from a single, sealed box to the edges of cosmic comprehension. It began with a cat, a paradox designed to highlight the absurdity of applying quantum rules to our world, and it has led us to the breathtaking possibility that the absurdity is the very fabric of our existence. We've navigated the fuzzy probabilities of the subatomic realm, witnessed the universe branching with every quantum decision, and confronted the startling idea that our own consciousness might be either a powerful sculptor of reality or a multitude of experiences scattered across a multiverse. This journey has challenged the core of what we consider real, solid, and singular. While the definitive proof of a superposed universe remains just beyond our scientific grasp, the power of this idea is not in its certain truth, but in its profound ability to expand our imagination. It forces us to question the nature of our own identity, the weight of our choices, and the very meaning of a single life. It suggests that the solid ground of our everyday experience is a magnificent, necessary illusion, a stable branch we cling to in an infinite, raging river of possibilities. Whether you find the many worlds interpretation elegant or extravagant, its true value lies in the perspective it offers, a cosmic vantage point from which our struggles and triumphs are both uniquely precious and part of an unimaginably vast tapestry. So, as we close this box for now, we leave you with a thought to carry into your own reality. The next time you stand at a crossroads, whether it's a major life decision or a simple, everyday choice, pause for just a moment. Consider that in the grand, shimmering quantum field of existence, there is another version of you, born from the same source, who is making a different choice at this very instant. That other path is real, with its own joys and sorrows, its own unique story unfolding. What does that mean for your reality? Does it make your journey feel less significant, or does it imbue it with a new kind of freedom? The answer to that question may be the most personal experiment of all. We would love to hear your perspective. What does the idea of infinite selves mean to you? Share your thoughts